This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and today I'm joined by Heather Johnson, who's in the School of Education and Human Development at the University of Colorado, Denver. Heather, thanks so much for being here.
Thank you, Sam.
We're going to be talking about Heather's article called A Link Between Students' Discernment of Variation in Unidirectional Change and Their Use of Quantitative Variational Reasoning. And that's published in Educational Studies in Mathematics, Volume 97. And the exciting news is that's actually an open access article, so everybody right now can go ahead and get full access to that article, which is really great. Heather, thanks so much for doing that.
I'm thrilled that we were able to make it happen.
So that article gets into ideas of variation, but variation in rates. And for me, I'm very interested in this topic because of real-world connections. A lot of people say that at the primary grades, there's plenty of real-world connections for all the mathematics that kids are learning. But once you get into secondary mathematics or college mathematics, it's really hard to make the real-world connections anymore. But for me, I see lots of rates in the world. There's growth rates, there's graduation rates, there's birth rates, there's death rates, there's economic rates that are happening. And I also see a lot of people maybe get confused about what it means to have a change in the rate of something versus like just a holistic net change itself. So we're going to get into some of the ways that kids think about and understand this idea. But Heather, before we get to that, I always like to start kind of at the beginning. So what was it that led you to pursue a PhD in math education?
Well, Sam, I started off as a high school mathematics teacher, and I spent 13 years teaching high school students math in South Central PA. And I taught students across a range of courses, including courses called things like basic algebra and other ones called things like advanced placement calculus. And one year, I taught students in basic algebra right after a section of my advanced placement calculus course. And my students would come in and see things on the board and say things, we can't do that. It's too hard for us. And, that really bothered me. Mm-hmm. And I started talking to my students and saying things like, well, sure, there's lots of formulas and equations on the board, but you don't have to be in calculus to make sense of the ideas that are underlying these things. And when I would talk to parents at Parents' Night, I would say, really introductory calculus, it just answers two questions with a cool plot twist. How much is changing at a particular instant? Like how fast is something changing at a particular instant? And how much has accumulated in an interval? And the plot twist is that they're two sides of the same coin. Mm-hmm. And so I ended up in graduate school because I was doing presentations for teachers in Pennsylvania, and I kept running into my undergraduate academic advisor, Glenn Bloom. And he had mentioned to me that they had this really cool grant going on at Penn State, and I'd be a great fit for it. And so I kept telling him no, I'm really not interested. And then I thought, if I keep telling him no, he might think I'm actually not interested, and that scared me more. So I took the plunge, and here's history.
Mm-hmm. So that took you to Penn State.
Mm-hmm.
What were your grad experiences like at Penn State, and who did you work with there beyond that project even maybe?
My primary advisor was Rosemary Zabik.
Okay.
And my dissertation title was Making Sense of Rate of Change, Secondary Students' Reasoning About Changing Quantities. And so as we can see, it's not really come that far from where I started. And, two experiences that really stand out to me at Penn State, being part of the Mid-Atlantic Center, we had a chance to connect with faculty across different institutions and also other grad students. And so every year we'd have a conference where we'd get a chance to meet and connect and explore with other folks. And that was really interesting. The other experience relates to my committee, and it was made up of two math educators, Glenn and Rose, and then a mathematician and a language and literacy person. And something that I can tell you is after a mathematician asks you to define something, and then you have a language and literacy person say, how might you define this term? it's important to know that you're no longer being asked by a mathematician. And that is something that I'm very grateful for Rose about, because I froze. The language and literacy person asked me to define a term after I had been talking about the completeness of the real numbers, and I looked and I said, I just don't know. And Rose looks at it in a deadpan voice, says, Heather, the mathematician's not asking you the question. And we all laughed. And we went on. And, when I think about perspectives, it was so powerful for me at Penn State to be able to feel freedom to network different perspectives and think about things from different ways. And that's something that I've really carried forward.
So you mentioned the dissertation about rate of change, and now this article in Ed Studies in Math is focusing on variation in unidirectional change. So I was wondering if you could just talk us through the connection between this article and your previous work, and also if there's kind of a backstory for this particular study and how it came about.
Well, and so in my program of research, I've been working to investigate a pretty singular question, which is, how do students come to conceive of variation in unidirectional change? Or, to put it another way, how do students conceive of things like increasing increases? And as you can hear, even the language around this stuff is challenging. Like, we don't have a good word for what is an increasing increase. And so,
or you can just listen to me in the intro where I didn't know quite what words. I know what I'm seeing and getting at, but I also don't have the words for that.
And when I think about where this research can go eventually, how we as scholars can even start to begin to think about building up some of these language around these ideas is useful. And when I think about, why this question even matters, like you mentioned at the beginning of the talk, we hear about varying rates in the news quite often. And in fact, when I think about some things, my first blog post was actually just about varying rates in the news. And even, you sent me, after we talked about this podcast, you sent me a post about the rising sea levels. And not only is the sea level rising, but the rate of sea level rise is increasing. Ideas like this are really important for us as informed citizens, but how do students even come to make sense of these ideas? I was talking with Marilyn Carlson at the Room Conference this weekend, and one of the things that I mentioned to her was, how do students come to think that a graph that we might have as like a line graph, a linear graph, when isn't that good enough to show the kind of increase that students might want to talk about? How might they notice that there's something more going on there, and might they even want to show that there's something more going on there? And so it's those questions and thinking about how things like increasing increases become things for students is really what is kind of building this talk from the ground up.
So in the article, which you wrote with Evan McClintock, you designed an experience for students, and it's a design experiment kind of study. And so I wondered if you could just talk us through the main elements of that design experiment, and what were you actually trying to have the students experience when you worked with them?
So the design experiment operated on a couple of levels. One, we were conducting this design experiment in a school that was hyper-segregated. Just about all of the students at the school identified as students of color and were eligible for free and reduced lunch. And we were fortunate enough to be able to have an opportunity to actually teach lessons in the school. And so we needed to work with a teacher to negotiate an experience that would meet both research and practice goals. So one of the teacher's goals had been to have a review unit on linear function. And the teacher was willing for us to do a replacement unit that could still meet the goals of review, but also meet our research goals. And so in our design, our question, we were investigating how students might discern this variation in unidirectional change. And so we had looked at this experience with constant rates of change in the classroom, and then, or linear situations, and then we also looked at in the follow-up interviews how students attended to this variation in change, settings where they might have an increasing increase. And so with the design, we thought about theoretically the design on a couple of levels. I talk a lot about networking theories of different grain sizes. And so Martin's variation theory, which looks at how students might learn across instructional settings, helped us to think about how we might frame the experiences that students were working on. So Martin argues that there's two things that are useful for students in learning: discernment and variation. When we think about variation from Martin's perspective, I understand him to be talking about it as difference, that this idea that our learning experiences are based on differences. So for example, Sam, when I was prepping for this talk, I mentioned that I listened across so many of your podcasts because I wanted to get a sense of what is a Sam Otten podcast across all of these. And I couldn't do that by listening to just one. I needed that variation. And so when I think about this design of this study, it's not just looking at linear situations or not just looking at situations that have variation and change, but it's across those things. And then second, I mentioned about it's one thing to have a good task that it's engaging, and it's also to add another layer to think about how we can use theory to do work to augment our tasks. And this is where Thompson's theory of quantitative reasoning really comes in for me. That if we think about how students are actually conceiving of the attributes that are in the task, what are the attributes? How are we working with them? How are we building up ways for students to conceive of those? I use that theory to help me work on the tasks to be able to craft these kinds of experience that I thought might, what we call, engineer opportunities for students to engage in this reasoning. So if it's going to happen, how can we create settings where we can hopefully create that likelihood as much as possible?
So you taught some of the whole class sessions using that kind of review replacement that you described, and then you pulled 14 students for interviews afterward. So is there anything else we need to know? And I know people should go to the article because it's open access. They should go for the details of the method. But anything else you want to share about how those interviews were conducted or how you looked at the data from those interviews?
So the interviews were conducted with pairs of students, and I taught lessons across 4 different sections of their 7th grade pre-algebra classes. And so they were all 7th grade students near the end of the year taking a pre-algebra course. And then I picked pairs of students. I selected those pairs based on students who were willing to talk in class. And I chose that because in an interview setting, it's so important to be able to have students who are willing to talk to someone they're just getting to know. I wanted to be able to have a situation where I thought that students would potentially feel comfortable to talk with me about these ideas. And so when we looked at this, I was careful to pick at least one pair of student from every section. And in the class, they had worked with the filling rectangle animations that I describe in the article. And then in the follow-up interview, we started with the filling rectangle and then moved into a filling triangle situation, which had that variation in the unidirectional change. In our analysis, we then went through a couple of phases to layer some of these different ideas, beginning with how did students conceive of variation in the attributes? Were they giving us evidence that they were thinking about these attributes as varying? And then how did they conceive of measuring the attributes? Were they talking to me about how they were thinking about these different properties as things that, not that they were calculating so much area, but how were they thinking about area as something that they could measure? And then, did they give us evidence that they were thinking about this variation in unidirectional change? I mean, something that I think is so fascinating when I work or use tasks with students, and those tasks might have what I perceive to be variation in unidirectional change. So much of the time, students aren't attending to that because I think that the way they're thinking about change, just the direction is enough. And so I've been fascinated when, how does the direction not be enough and we move into needing something a little bit more? And so in our analysis, we really tried to bring that up to who are the students who are conceiving of something a little bit more, and what evidence do we have to explain kind of how that perhaps came to be.
And I also encourage people to go to the article because you have nice pictures of this representation, or it's really a linked representation of the rectangle or the triangle, its area filling up, and that is simultaneously linked with this curve being drawn, and so you can see the increase and you can see the increase, but the changing increase as it goes. So I encourage people to look at that in the article. My guest is Heather Johnson from the University of Colorado at Denver, and now I just want to go to what the main finding of your analysis was. So let us know what kind of the main thing that jumped out from you when you did this whole experience and interview.
And the main finding from the analysis is that the students who conceived of variation in unidirectional change, or the students who gave us evidence of conceiving of increasing increases, were also those students who conceived of attributes in the task of capable of varying and possible to measure. Or to put it another way, those students who engaged in quantitative variational reasoning, or QVR, which we abbreviate throughout the article.
So let's unpack that a little bit. Can you give us kind of an example, or maybe talk us through a student that kind of represents that main finding?
Absolutely. One of my favorite parts of the article is Tomas's reasoning. And when we had asked students to sketch a graph that was relating the area of the filling triangle and the length of the height of that triangle. And Tomas did something that I hadn't seen before. And what he did was, instead of sketching what I intended, which was the triangle filling as it began at the base and then increasing the entire way up, we had set up the animation so that the amount of area was a part of the way through the triangle. And in the article, in figure 5, you'll actually see where it was when I pressed the animation. And so what happened was the animation, the triangle filled up to the top and then came back and refilled to that beginning. So instead of like a whole filling, what Tomas saw was filling the whole way up and then coming back. And what he sketched was exactly that process of the triangle filling up, slowing down at the top, and then getting fast again at the bottom. And at first, we were thinking, how is this happening? This isn't what we were expecting. And diving in to think about one of my favorite parts that happens in data analysis is when students do things that wasn't exactly what I was thinking was going to happen. And to me, I'm smiling right now because that's just, it's like the most delightful part, because that's when the interesting stuff happens. And so when we talked about this conceiving of the attributes capable of varying and possible to measure, Tomas wasn't conceiving of the attributes that we had expected. He wasn't really focusing on the length of AD. What he was thinking about instead was how this attribute of area was changing as the triangle was filling. And he had given us a lot of evidence of how that attribute of area had made sense to him in terms of how much filling there was within the triangle, which is how we used evidence that he was engaging in quantitative reasoning at this point. And then he had also given us a lot of evidence about conceiving of this change in progress. And Carlos Castillo Garso talks about the construct of smooth images of change, which we also wrote about in an article that I had the good fortune of co-authoring with Carlos and Kevin Moore. And when we think about smooth images of change, it's not about the setting. Like, it's not about whether the task is discrete or continuous. It's about how children are conceiving of that change as progressing. And so with this quantitative variational reasoning, we were really trying to work on students are conceiving of these attributes as capable of being possible to measure and also capable of varying, not as having been changed and then think about it, how it happened at the end. And so with Tomas's example, this attribute of area he could conceive of as possible to measure, and then also as capable of varying. And it was really exciting. There's always so many stories you want to tell that in 8,000 words, including references, don't have the opportunity to fit in. Earlier in that interview, Tomas had really been focused on the numbers. In the analysis section, we brought up with Tomas in table 3 that we had given an example of Tomas with the numerical code, where he said, well, it goes 1 to 10 real fast. And then once it gets to like 20 and 21, it starts taking, like, it goes more slowly. Whenever students use pronouns like it, one of my favorite things to say is, so what's it? Can you point to, can you show me? Can you talk about this? And so he went from talking about these numbers to beginning to talk about this attribute. And one of the things that I love about working with students in areas like this is that we have so much to learn from students, and we're just figuring out how students come to make sense of these kinds of things. And so I feel like I have the opportunity to put students in a place of, talk to me about your ideas. Like, help me to think about what you're showing so that we can learn from you. Whenever I work with students, and my research has generally focused on students at the secondary level, maybe middle school or high school, and one of the things that I always tell them is, you're the expert in this interview. I am going to learn from you. You're helping me to learn more about students' thinking because we don't know enough about this. And so when you share with me how you're thinking, that's where we learn. And Sam, I can think of a recent interview that this has just stuck with me, not about this study, but a student recently, this past spring, I asked him a question and he looks at me and he says, do you want me to tell you what I think or what I'm supposed to say? And I said, I want you to tell me what you think. And the way that his body language changed and the experience, and when I share it, those are the kinds of things that I think about when I'm working on these papers, that I don't know that that in the writing of, reporting the analysis and making sure that we keep everything tight, I am pressing myself to become more aware of how much those stories need to be told just as much as the ones that you'll see in here. And when I think about this, that's something that, is really a way that I frame these things. So I think I took a really roundabout way of answering your simple question of, could you give me an example? But for those who know me well, I do seem to have a gift to make a short story long. And the point to take from that is, when we pay attention to our students, it's too easy to miss the reasoning that they have because it's not what we necessarily expected to see. And it's in cases like Tomas, where how he was conceiving of these things as capable of varying and possible to measure, it's really where the magic happens when we sit back and notice and pay attention.
Yeah, no, that's great. And I'm glad that you had the opportunity to share that part of the story here, because, it's very hard to get those into the printed, for lots of reasons, into the printed form. Now, I do want to go back at the beginning. You talked about some other scholars' work, Martin and Thompson, for example, that helped you frame this study. But now that you have your findings, now that you have thought through what you saw from the students and learned from them, now how do you relate this study to other scholars' work on variation or covariation?
Well, in particular, I can really relate this work to Thompson and Carlson's 2017 variational and covariational reasoning frameworks. And so what I'd like to do is talk a little bit about how I see this construct of quantitative variational reasoning as aligning and working with that framework. So when I think about Thompson and Carlson's covariational reasoning framework, I see quantitative reasoning as underlying that framework. And I mean, in the beginning of the chapter, Thompson and Carlson spend a great deal of time talking about this theory of quantitative reasoning. And then they provide a variety of different levels in the way that students can engage in variational reasoning. And I see this quantitative variational reasoning as extending across a few of the different levels. Like I said earlier, when I think about quantitative variational reasoning, what we intended to communicate is that it's this form of reasoning that incorporates both conceiving of attributes as capable to measure, quantitative reasoning, and conceiving of attributes as capable of varying, smooth images of change. In Thompson and Carlson's framework, you'll see that there's the gross variation level and then also the smooth continuous covariation level. When I think about this quantitative variational reasoning, I feel like gross variational reasoning isn't quite enough to describe what I'm thinking about with the quantitative variational reasoning, and yet I really appreciate how Thompson and Carlson talk about how any level in the covariational reasoning framework implies that all the levels below it have also been developed, and that there's this reasoning that encompasses all of the levels below. And so when I think about how Thompson and Carlson describe smooth continuous covariation, and I think about quantitative variational reasoning, I didn't design the study to gather the kind of evidence that would, for every student, necessitate all of those different levels. And when I think about it, it's interesting to explore more in terms of how quantitative variational reasoning might fit in with that. Are we, thinking about, like I said, something that kind of can live alongside? I'm not suggesting that I think we need more levels. I'm saying that I think it is giving us something that I really appreciate about the framework, and also how I see it as aligning with what we're doing, is we're having more ways to think about how students are conceiving of variation.
We have a little bit more of a smooth variation between those, maybe.
I like that.
Moving from the kind of the intellectual space of trying to really understand kids thinking about this, going into the practical side, what do you see as some of the implications for teaching? If you were talking to teachers now, specifically about this article, what would you say to them?
Yeah. So when I think about the implications for teaching, I've actually been talking with folks on Twitter about implications based on this. And something that I've talked about just kind of in brief is to think about the kinds of attributes that we're including on the axes. And so I wrote a blog post back in April titled Graph Makeover, It's About Time. And the question said, think back to a time when you encountered, and I put in quotes, a real world graph in a math class. What was on the horizontal axis? And probably time. One of the things that I was suggesting was that we could begin to think about the kinds of attributes students have opportunities to think about when they're working with graphs. And I mean, I'm not the only one who's worked on this in research. Like if you think about Kevin Moore's line of research with breaking conventions and having students think about different graphs, there are other scholars who are looking at this. When you ask the question of how does your study inform practice, I'm really trying to use some of these findings to get the word out of what are the attributes we're using and how might that matter? And what are students having a chance to work with? And so that's one practical, like just one way that I think of, like for work with teachers, for work with task designers. So recently we had published a special issue in ZDM with David Clark, Alf Coles, and I, and the article was titled A Tension of Intention between instructional designers, teachers, and students in terms of what are all of our goals. And so when I think about another claim, I think about an implication for instructional designers in terms of it's one thing to have an engaging task. I'm encouraging us to think about ways that we might add value to engaging tasks. So how might we take something that students really like and use results of research to be able to kind of dive deeper and really use the theory to inform, to add value to those particular tasks. And when I think about the filling rectangle and the filling triangle tasks, I now see us as adding some value to some of those kinds of experiences of dynamic computer environments, because those have been around for a long time, as to how might we really problematize what we're looking at so that we can create experiences that both engage students and leverage what we know from theory to intentionally design more opportunities for learning.
Heather Johnson is from the University of Colorado at Denver. She's on Twitter, as she mentioned, at HeatherLynn There's no vowels in there, except the Y, maybe, I guess, or sometimes Y. Heather Lynn J. Heather, before you go, it's been really fun talking about your work, but I also am curious, if you weren't in math education, what might you be doing instead, or can you imagine something else?
You told me that I could answer this question realistically or fantastically. And I talked with Evan McClintock about this last night, and I said, Evan, Sam asked me what I want to do. I don't usually give myself the space to think about, like, what could possibly happen. And so I probably thought about this question even more, or maybe just as much as the others. But I think that I'd probably be a teacher or an instructional coach if I weren't a professor. If anyone had told me that I would be writing for a living, I would have scoffed. I didn't even fully understand how much writing would be part of my career when I went into grad school, for what that's worth.
With regard to the writing, it makes me think of something that Joan Farini-Mundy said back at Michigan State. She's at NSF now, obviously, but when we were just early career researchers, early in grad school, she said to us, the research side of your job, what you're actually learning to do is to be a writer, and your genre of writing is this academic mathematics education. And that really sunk into me, because I kind of then realized, like, okay, this writing stuff is not just after the fact, it's not just to the side, or it's not just a hoop you have to jump through. No, that is actually the research part of the job, and it's a particular genre of writing, so that we have to learn that genre. And congrats on the article here and your other work. And I just will point out that you are willingly writing more than you have to, because you're also doing your blog. So you've taken up even more writing than required.
Yes, it's one of the things that I've really had now in my career is to try to think about how can we help build up writers in our profession. And so it's been, you mentioned genres, and it's been exciting for me to learn different genres of writing across the field. And if I think back to variation theory, I think that learning different genres of writing is actually helping me to learn the genre of mathematics education research even more, because thinking across communicating my messages in lots of different outlets has been a really fun opportunity, and has helped me to learn more about genres than I ever realized that I would.
Yeah.
And the other thing, though, if I think about something that seems fun, probably because I don't know it well enough, is civil engineering.
Oh.
Because I think it is fascinating to take a problem, like to design a traffic pattern and think about how you might solve it. I think I would really not enjoy all the other things that go into it. So I think the only reason why I mention it is because it's just at the idea phase.
Yeah.
As I was talking with Martha Alibali on Twitter about this, the ideas are so tantalizing. Like, I love ideas. And I feel like we have so little time and so many ideas. And one of the hardest things for me is to think about, which ideas do I take the time to evaluate? Like, to actually play out and work through, because in the idea stage, they're all so fun and they all seem so cool. And then when I sit down and work, you realize how much work it is to extend and expand and really turn those ideas into knowledge. And so that's something that I think about. This question, you took me on the idea train. Thank you for encouraging me to explore some ideas and have fun with that, Sam. It's been a pleasure.